Does the dimension of an antenna play a significant role in the reception of an electromagnetic wave?
The length of an antenna determines the frequency that it best receives. The most efficient antennas have a length equal to half the wavelength of the wave it is receiving. This allows the induced electrical current in the receiving antenna to resonate at that particular frequency. If the antenna is a simple rod, it is most sensitive when its length is 1/4 the wavelength. A loop or coil antenna are used for the low frequency, long wavelength signals in the AM band. A half wavelength straight wire antenna would be over 100 meters long. Shorter wires or rods can be used and are more efficient if coils of wire are used to load the antenna. Home FM radio and television antennas are designed to receive a broad range of frequencies, but with less sensitivity. Antennas for the ultra-high frequencies used in digital high-definition televisions are very short and can be easily mounted outside on rooftops or on top of television sets.
What is the origin of the masses of the quarks and leptons?
Peter Higgs, 1929, a British physicist, proposed a mechanism that gives rise to the masses of the quarks, leptons, and the two weak interaction bosons, the W and Z. The mechanism successfully predicted the mass of the Z boson, but it requires the existence of a particle, called the Higgs boson. Despite many searches, the Higgs boson has not yet been discovered. Physicists hope that the Large Hadron Collider, LHC, that started operation in 2010 will accelerate protons to high enough energies that the Higgs will be found.
What is an inertial confinement?
Method of producing nuclear fusion by using lasers to compress tiny amounts of a deuterium-tritium fuel mixture.
What is refraction?
Refraction is the bending of light as it goes from one medium to another. The most common use of refraction is in lenses. Eyeglass lenses refract light so that the wearer's eyes can focus the light properly. A magnifying glass is used to see enlarged images. Lenses in cameras produce an image on the film or CCD sensor. Refraction also occurs when sunlight strikes Earth's atmosphere and when it goes through water.
What is an opaque material?
An opaque object is something that allows no light through it. Concrete, wood, and metal are some examples of opaque materials. Some materials can be opaque to light, but not to other types of electromagnetic waves? For example, wood does not allow visible light to pass through it, but will allow other types of electromagnetic waves, such as microwaves and radio waves, to pass. The physical characteristics of the material determine what type of electromagnetic waves will and will not pass through it.
What is an elastic deformation?
When the deforming force is no longer applied, object returns to its original shape. See plastic deformation.
What is the weak nuclear force?
Cause of beta decay. Weaker than strong nuclear force. Shown to be an aspect of the electroweak force. Carried by the massive W+, W-, and Z degree particles.
What is an electroscope?
An electroscope is a device used to measure the charge on an object. It consists of two metal leaves, either thin aluminum foil or gold leaf, attached to a metal rod. If you touch a charged object to the metal rod, the two leaves will be charged with like charges, and so they will repel each other. The larger the charge, the greater the angle will be between the leaves.
What is a wave velocity?
Depends upon the material or medium in which it is traveling.
What is temperature?
Temperature is a quantitative measure of hotness. In many substances, temperature is proportional to the thermal energy in the object. But the relationship between temperature and energy depends on many factors.
Are there yet more quarks and leptons?
There are two more generations of both quarks and leptons. In the second generation, the quarks are called strange and charm. The strange quark was named after particles that contain these quarks. The particles decayed in very different ways and were therefore called strange particles. The charm quark was found in a particle that had a very long, or charmed life. The leptons are the muon and muon neutrino. The muon was first called the mu meson before its true identity was discovered. In the third generation, the quarks are called bottom and top. The leptons are called tau and the tau neutrino.
What is speed?
If something moves from position to position, then speed is a measure of how fast it moved. Speed is defined as the distance moved divided by the time needed to move. Both change in position or distance and time are measured quantities. Frequently, speed is called the time rate of change of distance. For example, if you drive 240 miles in 4 hours, then your speed is 60 miles per hour, abbreviated mph. It is unlikely that you drove the whole trip at a constant 60 miles per hour. This example calculated your average speed. If you were pulled over for speeding and were told you were going 80 miles per hour, you wouldn't be able to avoid a ticket by saying, "But officer, my average speed is only 60. The vertical lines you see on a map or globe are lines of longitude, and the horizontal lines are lines of latitude.
What is the Coulomb's law?
Describes the strength of the electrical force between two charged objects. F equals K, Chi Q2/R2.
What are some things you should do if caught in a lightning storm?
The safest place to be during an electrical storm is inside a building. Where you should stay away from electrical appliances such as the phone and television, as well as all plumbing and radiators. Or car, but if you are unable to shield yourself in this way, the following precautions should be taken. Crouch down on the lowest section of the ground, but do not let your hands touch the ground. If lightning strikes the ground, the charges spread out sideways and can still reach you. If only your feet are on the ground, especially if you're wearing rubber-soled shoes. This might limit the amount of charge that passes through your body. If you must lie down because of an injury, try to roll up into a tight ball. Take off and move away from all metal objects unless they act as Faraday cages. Refer to the question about Faraday cages. Move away from isolated and tall trees. Avoid the tops of hills or mountains and open areas such as water and fields. If out on a lake or on the ocean, get back to shore as quickly as possible. If that is not practical, get down low in the boat and move away from any tall metal masts or antennas.
What is Nexred Doppler radar?
NEXRAD, or Next Generation Weather Radar, is one of the most recent technological breakthroughs for weather forecasting. NEXRAD relies on the Doppler effect to calculate the position and the velocity of precipitation. The spherical NEXRAD radar tower emits radar waves 360 degrees around and calculates the frequency shift of the reflected radar waves off rain, sleet, and snow. The NextRed computers then translate the information and represent the possible weather problems on a color-coded map for analysis. The maps are readily available in real time over the web. The goal and main function of NextRed precision radar is to save American money and lives. By predicting threatening weather problems and warning the public before tragedy strikes. Meteorologists estimate that this new tool for weather forecasting has saved millions of dollars and many lives through its early warning systems. One of the most impressive advancements has been in pinpointing tornadoes and hurricanes more accurately than what was possible before NextRed. Each NextRed station scans a radius of 125 miles with excellent accuracy, and less accurately up to 200 miles. A new system, developed since 1994, is Terminal Doppler Weather Radar, or TDWR. This system, installed at 45 airports, uses radar waves with 5 cm wavelength rather than the 10 cm, 3.9 inches, used in standard weather radar. As a result, it can resolve objects with twice as much detail, permitting it to detect wind shear and microbursts. Its range, however, is half that of NextRed, and it can't see through heavy rain. Radar images are available to the public at www.radar.weather.gov.
Who really discovered oxygen?
Three scientists are often credited with the discovery of oxygen: Carl Wilhelm Scheele, Antoine Laurent de Lavoisier, and Joseph Priestley. The Swedish scientist Scheele discovered what he called fire air in 1772. The name came from the way an ember would burst into flame when immersed in the gas. Scheele wrote a book describing his work, but it took 4 years to be published. In the meantime, Priestley in 1774 discovered what he called dephlogisticated air. Lavoisier, who met Priestley in 1774 and was told about Priestley's discovery, claimed to have discovered what he called vital air. Although he was sent letters from both Scheele and Priestley describing their earlier work, he never acknowledged their receipt. Lavoisier's great contribution was to make precise studies of the role of oxygen in a variety of reactions and to give it the name oxygen.
How is atmospheric pressure measured?
A device to measure gas pressure is called a barometer. There are two major types of barometers, the mercury barometer and the aneroid barometer. Galileo's secretary, Evangelista Torricelli, 1606 to 1647, the unit of pressure. The Tor, was named after him, developed the mercury barometer in 1643. It consists of a thin glass tube about 80 centimeters, 31 inches, long, which is closed at the top, filled with liquid mercury and placed upside down in another mercury-filled dish. depending upon the atmospheric pressure pushing on the mercury in the dish. The level of mercury in the tube will rise or fall because there is no air above it. By measuring the height of the mercury, which would usually be between 737 and 775 millimeters, 29 to 30.5 inches, high, atmospheric pressure of the atmosphere can be measured. The most common household barometer is the aneroid barometer, in which atmospheric pressure bends the elastic top of an extremely low-pressure drum. By measuring the amount the top bends, a measurement of atmospheric pressure can be determined. The aneroid barometer is often used in airplane altimeters to measure altitude. Since atmospheric pressure decreases as altitude increases, the aneroid barometer is an ideal instrument to use. It is much safer than the mercury barometer. Because mercury vapor is poisonous and the mercury must be exposed to the atmosphere.
What is a force, F?
A push or a pull on an object by an external agent, vector.
How do day/night rear-view mirrors function in vehicles?
When drivers traveling at night encounter a bright light from the vehicle behind them shining in their eyes, many will flip a tab on the underside of the rear view mirror to deflect the light up toward the ceiling of the car. The silvered surface of the mirror reflects approximately 85 to 90% of the incident light on the mirror, which is now directed toward the ceiling. The remaining 10 to 15% of the light is reflected by the front of the glass on the mirror. The mirror is wedge-shaped, thicker at the top than at the bottom. Thus the front surface is angled downward to allow the much smaller amount of light to be reflected into the driver's eyes.
What is thermal physics?
The study of objects warm and cold, and how they interact with each other.
In what units is force measured?
In SI, the metric system, force is measured in newtons, abbreviated N. In the English system, force is measured in pounds, abbreviated lbs.
How does a curved ball curve?
The curved ball experiences the Magnus force like the golf ball. The pitcher can give the ball a backward spin, creating lift, or a sideways spin, causing the ball to curve sideways. When a pitcher throws a knuckle ball, the ball spins very slowly. The laces on the ball create small forces that make the ball move erratically through the air.
When it is at its maximum height, does it stop?
At an instant in time it is indeed at rest. But it doesn't stay motionless for any time interval because the gravitational force keeps acting on it.
Does sound's intensity always follow the inverse square law?
Sound doesn't always spread uniformly. You may have experienced this if you shout while you walk through a tunnel. You hear echoes and a person at another part of the tunnel will hear you much more clearly than he or she would in an open area. Whispering chambers are often found in science museums. They are rooms with walls in an elliptical shape. If you stand at one focus of the ellipse and another person stands at the other focus, you can hear each other speak even if you whisper while other people in the chamber are talking loudly. Sound can also be transported through the ocean with less spreading using an acoustic waveguide. Similar to the way light can travel in an optical fiber, see the chapter on light. The ocean water can separate into layers at different temperatures. The speed of sound depends on water temperature, and if there is a layer of cold water where sound speed is lower under a layer of warmer water where the speed is higher, then some of the sound moving through the cold layer will be reflected at the boundary back into the cold layer, keeping it from spreading. The name of this channel is sound frequency and ranging, so far, channel. It is 100 to 200 meters below the surface in the cold waters off Alaska but 750 to 1,000 meters deep in the warmer Hawaiian waters.
What are the average surface temperatures of the planets in our solar system?
For the planets that have atmospheres, mixtures of gases surrounding the surface of a planet, the average temperature stays relatively constant because the atmosphere acts as a type of insulator. These planets have only small variations in the temperature. When a section of the planet faces away from the Sun, Mercury, on the other hand, with no atmosphere and an elliptical orbit, has very large differences. In the table below, the temperatures of Mercury, Venus, Earth, and Mars are taken on the planetary surface, while those of Jupiter, Saturn, Uranus, and Neptune are taken at the tops of the clouds, there being no solid surface on these planets. This plasmolampin apparatus you often see at science fairs and novelty shops emits streams of plasma, electrically charged particles that are found in everything from stars to television displays and fluorescent lights.
When was magnetism discovered?
the discovery of rocks that attracted certain metals is lost to history. As was the case with electrostatics, Aristotle, 384 to 322 BCE, credited Thales of Miletus, 625 to 545 BCE. With the first scientific discussion of the attractive power of the rock later called lodestone. The word magnet comes from the region of Greece where lodestone is found. But the power of lodestone was found by other people around the same time. At the time of Thales' life, an Indian surgeon, Sushreta, used magnets to aid surgery. In the 4th century BCE, the Chinese book of the Devil Valley Master says lodestone makes iron come. In the 11th century CE, the Chinese scientist Shen Kuo wrote about the use of a magnetized needle as a compass in navigation. By the next century, the Chinese were known to use a lodestone as a shipboard compass. 100 years later, the British theologian, Alexander Neckham, described the compass and how it could be used to aid navigation. Some people thought that the pole star attracted the compass, while others thought that the source was a magnetic island near the North Pole. In 1269, the Frenchman Petrus Peregrinus wrote a detailed paper on the properties of magnets. But the most comprehensive and famous work was written by William Gilbert in 1600. Gilbert concluded that Earth was a giant magnet.
What is a standard model?
Presently accepted description and explanation of subnuclear particles and their interactions.
What is radar?
Radar is an acronym for radio detection and ranging. A radar installation emits electromagnetic waves and detects the waves reflected from an object. It measures the time for the echo to return to find the distance of the object. The radar dish is constantly rotating, permitting it to find the direction of the object as well. Radar is used in many different arenas, but was first used in World War II to detect the approach of enemy bombers.
What happens to the thermal energy in the surroundings?
They get warmer, so their thermal energy increases. Then they transfer this energy to a colder object. Earth is warmer than the space around it, and so it radiates energy into space. When that energy reaches another planet or star, those objects are warmed, and so on through the entire universe.
Why are lightning rods effective in keeping tall trees and homes safe from lightning?
Lightning rods are pointed metal rods that are installed above a tree or rooftop to protect the object. The rod, connected to the ground by a metal wire, both encourages and discourages a lightning strike. The rod discourages the lightning strike by leaking positive charges out of its pointed top to satisfy the need for positive charge in the clouds. If the rod cannot leak out enough charge to satisfy demand, the stepped leader from the cloud is instead attracted to the rod, and a flash of lightning occurs. Therefore, the rod attempts to discourage lightning, but if it cannot satisfy the negative charge, it attracts the lightning to the rod instead of the tree or house. If the lightning rod doesn't have a good connection to the ground through the wire, it can increase the danger to the building. Often these heavy grounding wires come loose from the lightning rods, and if the rod is then hit by lightning, the charges will flow along the surface of the building to the ground and could cause a fire. The rods can become disconnected from lack of routine maintenance. It is wise to check these connections on a regular basis.
What are the different states of matter?
The four phases of matter are the solid, liquid, gaseous, and plasma states. Solid phases are found at lower temperatures, as the amount of internal energy increases. The material changes from the solid to the liquid and then to the gaseous phase and finally, under extreme conditions, to the plasma state. Water, for example, changes from ice, its solid state, to liquid water, and finally to steam, its gaseous state. The temperatures at which the phase changes occur depend on the properties of the material. In the solid phase, the atoms or molecules are held in rigid positions by the chemical bonds between them. They can vibrate, but not change positions. When the temperature is at the freezing point, the solid melts into a liquid. In the liquid phase, molecules, or small groups of molecules, can move easily past one another. In most liquids, the spacings between the molecules is slightly larger than in solids, giving them a lower density. In water, however, the spaces are larger in ice than in liquid, meaning that ice has a lower density than water, so it floats. When the temperature reaches the boiling point, the liquid becomes a gas. In the gaseous phase, the atoms or molecules have essentially no forces between them, so they are free to move independently. They are about 10 times further apart than in a liquid or solid, meaning that the density of a typical gas is 1/1,000 that of the solid. To enter the plasma state, one or more electrons must be removed from the atom. Plasmas consist of electrically charged particles. Plasmas are found in fluorescent lamps, in some television displays, in the upper atmosphere, in the Sun and other stars, and in interstellar space.
What is a pulley?
Simple machine. A fixed, or unmovable, Single pulley can be considered a wheel and axle where both have the same radius. The mechanical advantage is 1, but the pulley changes the direction of the force. If the pulley is allowed to move, you achieve a mechanical advantage of 2.
What is a dispersion?
Light of different colors are refracted into different directions caused by wavelength dependence of refractive index.
What were uses of the Leyden jar?
In the late 18th and 19th centuries, people attempted to use the Leyden jar in a variety of ways. Some felt that it could cure medical ailments, and many doctors used the jar as primitive electroshock therapy. Others used it as a demonstration device and for entertainment purposes. Still more people felt that it could be used in cooking. Try cooking a turkey with an electrical spark.
What happens if the ball is launched at an angle?
The ball would now have both an initial horizontal velocity and an initial vertical velocity. Again, the horizontal velocity would be constant because there is no force in that direction. Its vertical velocity would be the same as it was when the ball was thrown either down or up. An initial upward velocity is much more interesting, so let's consider that. We can specify the initial velocity 2 ways. First, the way we did before by choosing the horizontal and vertical velocities separately. The second, and more useful way, is to specify the velocity and direction. Suppose a batter hit a baseball at a speed of 90 miles per hour. This speed is 132 feet/s or 40 m/s. The angle could be anything from 90 degrees. A vertical pop-up, down to an angle between 10 degrees and 30 degrees. That might be called a line drive to 0 degrees, or even a negative angle that would be a ground ball. The distance the ball travels before hitting the ground depends on both the speed and the angle. If air drag is very small, then the distance is maximum for an angle of 45 degrees. Air drag causes the angle for maximum distance to drop to around 35 degrees. During World War II, extensive tables were calculated so that gunners could find the angle for the gun to achieve the desired distance.
What is a torsional force?
Force exerted to twist an object.
How do refrigerators and air conditioners work?
As you know, when a liquid evaporates into a gas, it is cooled. Heat flows into the system. The opposite process. The condensation of a gas into a liquid results in an increase in thermal energy and an output of heat. A refrigerator circulates a refrigerant, a liquid that evaporates at a low temperature. Through tubing, the gas is compressed by an electrically driven compressor. The pressure and temperature of the gas increases. Coils of the tubing outside the refrigerator cool the liquid and heat the air around them. As it cools, the refrigerant condenses back to a liquid that goes through a tiny hole, called the expansion valve. The pressure drops, evaporating the liquid, making the gas cold. The tubing containing the cold gas is in the inside of the refrigerator, making it cold, and cooling the food. An air conditioner works in a similar way. The evaporator is in the unit inside the house and the compressor is outside. Because of the work put into the compressor, heat is removed from the air inside the house and transferred to the outside air. The diagram below shows work and heat flows in a refrigerator or air conditioner. The first home refrigerators used ammonia as a refrigerant, but ammonia is toxic. In the 1930s, Freon was first developed by the DuPont Company of Wilmington, Delaware. Freon is a chlorofluorocarbon, CFC. If freon escapes, it carries chlorine atoms to the upper atmosphere. Their ultraviolet radiation from the sun separates one of the chlorine atoms from the CFC. That atom converts ozone back to oxygen, contributing to the destruction of the ozone layer, an essential barrier against harmful ultraviolet sunlight. Freon's destructive nature has been known since the 1970s, but it was not until the early 1990s that legislation was implemented banning the use of freon in new air conditioners and refrigerators. It has been estimated that in 2002 there was 6 million tons of freon in existing products. Unfortunately, when the chlorine destroys an ozone molecule, the chlorine is not destroyed, but instead continues to live for a while, destroying more ozone. In fact, more freon is still headed toward the upper limits of the atmosphere. For it can take several years for freon to reach such elevations. DuPont and other corporations have developed replacements for freon that replace the chlorine atoms with hydrogen atoms. These substances do not harm the ozone layer and are in use in refrigerators, air conditioners, and aerosol cans.
What is a concave mirror?
Curved inward so that the incident rays of light are reflected and can be brought together. Can form real or virtual images.
What is a rod?
Rod-shaped nerve cells on the retina that sensitive to low light levels. Responsible for a general image over a large area, but not fine details.
What is Newton's first law?
If there is no net force on an object, then if it was at rest it will remain at rest. If it was moving, it will continue to move at the same speed and in the same direction.
What famous scientist was placed under house arrest for agreeing with Copernicus?
Galileo Galilei, 1564–1642, was responsible for bringing the Copernican system more recognition. In 1632, Galileo published his book Dialogue concerning the two chief world systems. The book was written in Italian and featured a witty debate among three people. One supporting Aristotle's system, the second a supporter of Copernicus, and the third an intelligent layman. The Copernican easily won the debate. The book was approved for publication in Florence but was banned a year later. Pope Urban VIII, a longtime friend of Galileo, believed that Galileo had made a fool of him in the book. Galileo was tried by the Inquisition and placed under house arrest for the rest of his life. All of his writings were banned. Galileo was also famous for his work on motion. He is probably best known for a thought experiment using the Leaning Tower of Pisa. He argued that a heavy rock and a light rock dropped from the tower would hit the ground at the same time. His arguments were based on extensive experiments on balls rolling down inclined ramps. Many scientists believe that Galileo's work is the beginning of true physics.
Who were the first physicists?
Although physics was not considered a distinct field of science until the early 19th century, people have been studying the motion, energy, and forces that are at play in the universe for thousands of years. The earliest documented accounts of serious thought toward physics, specifically the motion of the planets, dates back to the years of the Chinese, Indians, Egyptians, Mesoamericans, and the Babylonians. The Greek philosophers Plato and Aristotle analyzed the motion of objects, but did not perform experiments to prove or disprove their ideas.
What determines how much a material will bend?
Try to bend a ruler. Hold one end tightly on your desk and push down on the other end. You are exerting a tension force on one surface and a compressive force on the other. The amount the ruler bends depends again on the Young's modulus, Y, of the material as well as its length, L, width, W, and thickness, T. The bending, X, is proportional to the force applied, F, and the length cubed and inversely proportional to its thickness cubed. Or, in the form of an equation, X equals FL3/T3WY. That is why the joists supporting a floor are much thicker than they are wide. Typically wood 1-1/2 wide but 10 or 12 thick is used. The larger thicknesses are used if the span between supporting walls is longer. An I-beam is often used to support weight. The beam is in the shape of the letter I. The vertical member, tall and narrow, keeps it from bending while the top and bottom members keep the vertical member from twisting. While I-beams are most often made of steel, wood beams are now used in houses because they are stronger, lighter, and cheaper than steel.
What are electromagnetism and optics?
Studies how electric and magnetic forces interact with matter.
What is a flavor?
Generation of quark, up/down, strange/charm, top/bottom, or lepton. Electron/electron neutrino, muon/muon neutrino, tau/tau neutrino.
What makes up the nucleus?
Ernest Rutherford, 1871 to 1937, had determined that the charge on the alpha particle, actually the helium nucleus, was 2 proton charges, but its mass was 4 proton masses. Dmitry Mendeleev, 1834 to 1907, in building the periodic table, had arranged the elements in order of their mass and had arbitrarily assigned them sequential numbers that he called the atomic number. The English physicist Henry Moseley, 1887 to 1915, measured the wavelengths of X-rays emitted when metals were struck by other X-rays. He was able to provide a physical basis for the atomic number and, in doing so, greatly strengthened the case for Rutherford's nuclear model. But, as is the case for helium, if the atomic number, and thus the nuclear charge, was about half the atomic mass number, what made up the additional mass of the nucleus? The first proposal was that the missing particle was a combination of a proton and an electron, which would have the correct mass and charge. But the Heisenberg uncertainty principle showed that if an electron were confined to the size of a proton, its energy would be larger than ever observed. In addition, by the late 1920s the angular momentum of the nitrogen nucleus, with charge 7 and mass 14, had been measured. The result could not be obtained from a combination of 14 protons and 7 electrons. In 1931, 2 German physicists found that when energetic alpha particles struck light elements, a very penetrating, neutral radiation was produced. The next year, Marie Curie's daughter, Irene Joliot-Curie, 1897 to 1956, and her husband, Frederick, found that if this radiation struck paraffin, protons were ejected, suggesting that the radiation was actually a neutral particle with a mass near that of a proton. The next year James Chadwick, 1891 to 1974, working in Manchester, England, experimentally confirmed the suggestion. The particle was named a neutron, combining neutral with the ending of the word proton. He was awarded the Nobel Prize for his discovery in 1935. The neutron has a mass slightly larger than that of the proton. While neutrons are stable in non-radioactive nuclei, if they are free from the nucleus they decay with a half-life of about 10 minutes. Neutrons are used extensively in creating nuclear reactions and are necessary for nuclear fission, which will be discussed later in this chapter.
How does light become polarized?
Light can be polarized in two ways. If a shiny surface such as water or an automobile window reflects light, it can be partially polarized. Or, you can use a polarizing filter that passes only the light that has the electric field in one orientation. A Polaroid filter has long, thin molecules, all oriented in the same direction, embedded in plastic. The molecules absorb light that has an electric field parallel to the long dimension of the molecules. Therefore, the light passing through the Polaroid has an electric field perpendicular to the long dimension of the molecules.
What is Ohm's law?
In the early 1800s, George Simon Ohm, 1789 to 1854, a German physicist, developed the law that bears his name: the resistance of an object is independent of current through it. Many materials do not obey Ohm's law. For example, when the current through the tungsten filament wire in a lamp is increased, the temperature of the wire increases and so does its resistance.
What is a laminar flow?
Flow of slow-moving fluid or object moving slowly through a fluid. Each thin film of water moves slightly faster than the one closer to the surface.
What is the difference between pitch and frequency?
Frequency, like sound intensity, is a physical property. Pitch, like loudness, is a description of how the ear and brain interpret the sound. Pitch is primarily dependent on frequency, but depends somewhat on loudness. Timbre, and envelope, which will be discussed below. Humans hear pitch in terms of the ratio of two tones. The ear perceives two notes to be equally spaced if they are related by a multiplicative factor. For example, the frequency of corresponding notes of adjacent octaves differ by a factor of 2 notes. In common chords are related by ratios of 3:2, 4:3, 5:4, etc. In the same way, the perceived difference in pitch between 100 Hz and 150 Hz is the same as between 1000 Hz and 1500 Hz.
What are applications of this rule?
Autos and trucks that are narrower and have high center of gravities are less stable against rollover. Football players and wrestlers are taught to get down low and spread your feet apart. This stance follows the low and wide rule, making your body more stable and difficult to knock over. Your opponent, in order to knock you over, would have to exert a force to lift up your center of gravity and then push you over. If you simply stood upright, with your feet close together, you would be tall and narrow, and your opponent would have less difficulty pushing you and your center of gravity.
How did Dalton represent atoms?
Dalton used pictographs to represent atoms. Below, in the first line, are some examples. Dalton would represent a chemical reaction. Carbon plus 2 oxygen to yield carbon dioxide, as shown on the second line below.
What were the implications of Ørsted's discovery?
The fact that moving charge in a wire could create a magnetic field created a great deal of excitement and enthusiasm in the scientific community. A week after hearing about Ørsted's discovery, French physicist and mathematician André-Marie Ampère (1775–1836) gave a presentation at the French Academy of Sciences that extended Ørsted's experiments and contained detailed analyses. A day later he found that two parallel current-carrying wires would either attract or repel each other depending on the relative directions of the currents. Ampere's greatest contribution, however, was the mathematical theory he created for electricity and magnetism. British chemist and physicist Michael Faraday's 1791–1867 philosophy led him to search for connections between phenomena like electricity, magnetism, and light. In 1821 he invented what is now called a homopolar motor. One end of a wire was suspended from a support so that it could swing in any direction. The other end of the wire contacted a pool of mercury. When Faraday put current through the wire, the end in the mercury traced out a circle. The force that Faraday had observed wasn't formalized until 1891 and then by the Dutch physicist Hendrik Antoon Lorentz, 1853–1928. This force, called the Lorentz force law, is proportional to the current through the wire, the magnetic field, and the length of the wire. The force, which is perpendicular to both the current and the magnetic field, is strongest when the current and field are at right angles. This force is the basis of motors and many other applications. When Faraday published his results, he failed to give credit to two other important scientists, and he was given assignments to work in other fields. Nevertheless, he continued to do experiments on the effects of magnetic fields. For example, he found that when dense glass was put in a magnetic field, the direction of polarization of light going through the glass was rotated. He spent 10 years searching for ways to create a current from a magnetic field. Finally, in 1831 he tried changing the magnetic field and made the crucial discovery that an electric current is produced by a changing magnetic field. The current, a flow of charges, is produced by an electric field exerting forces on the charges. Faraday went on to invent the dynamo, an early electric generator. The American high school physics teacher Joseph Henry, 1797 to 1878, made the discovery at almost the same time.
What is mass, m?
A property of the object, the net force exerted on object divided by its acceleration, scalar.
How does the air become a conductor?
When the charges have enough energy to begin to ionize the air of the free electrons will form a negatively charged stepped leader that will go from the cloud and make its zigzagged and often branched trip toward the ground. This process is slow, taking a few tenths of a second. The leaders are also weak and usually invisible. The atoms in the air near the ground, feeling the attractive force from the electrons in the stepped leader, separate into ions and free electrons. The positively charged air ions from tall objects, such as trees, buildings, and towers, leave in streamers. When a stepped leader and streamer meet, a channel of ionized air is created, allowing large amounts of charge to move between the cloud and the ground. The return stroke of charge back to the cloud is the brightest part of the process.
How does gravity fit into the Standard Model?
It does not fit. Gravity, explained by Einstein's general theory of relativity, is extremely successful on the macroscopic scale. But, all attempts to create a quantum gravity have failed. So have attempts to fit gravity into the Standard Model.
Why is it dangerous to operate electrical devices in bathtubs, showers, and over full sinks?
Although water reduces the resistance of the human body and thus makes it more susceptible to electrical shock, It is the plumbing that is the main hazard. Take, for example, a person who likes to watch a plugged-in TV while sitting in the bathtub. If the TV is not connected to a GFI protected circuit and fell into the tub, the water would come in contact with the 120-volt wires in the TV. With the metal plumbing of the tub connected to ground, the grounding path would cause a current through the water. Unfortunately, this translates into a bad day for the bather. An MP3 player or battery-powered smartphone is much safer.
What does a physicist do?
Physicists normally do their work in one of three ways. Some are theorists who create and extend theories, or explanations of the physical world. Others are experimenters, who develop experiments to test theories to explore uses of new instruments, or to investigate new materials. The third method of doing physics is to use computers to simulate experiments, explore and extend theories, or make observations that cannot be done by the human eye. Physicists can find employment in a variety of fields. Many research physicists work in environments where they perform basic research. These scientists typically work in research universities, government laboratories, and astronomical observatories. Physicists who find new ways to apply physics to engineering and technology are often employed by industrial laboratories. Physicists are also extremely valuable in areas such as computer science, economics and finance, medicine, communications, and publishing. Finally, many physicists who love to see young people get excited about physics become teachers in elementary, middle, or high schools, or in colleges and universities.
What is Pascal's principle?
A fluid, like water, exerts the same pressure in all directions.
What are some typical power outputs?
The following table was adapted from Wikipedia's entry on orders of magnitude, power. Retrieved on November 13, 2009. Unit example * femtowatt, 10 to 15 watt, 10 FW, approximate lower limit of power. Reception of digital cell phones picowatt, 10 to 12 watt, 1 PW, average power consumption of a human cell microwatt. 10 to 6 watt, 1 carat W, approximate consumption of a quartz wristwatch milliwatt, 10 to 3 watt. 5 to 10 MW, laser in a DVD player watt, 20 to 40 W, approximate power consumption of the human brain. 70 to 100 W, approximate basal metabolic rate used by the human body. 5 to 253 W, per capita average power. Use of the world in 2001 500 W, power output of a person working hard physically 909 W, peak output power of a healthy human. Non-athlete, during a 30-second cycle sprint kilowatt, 103 watts, I. 366 kilowatts, power received from the Sun at Earth's orbit by 1 square meter up to 2 kilowatts, approximate short-time power output of sprinting professional cyclists. 1 kilowatt to 2 kilowatts, rate of heat output of a domestic electric tea kettle. 4 kilowatts, average power consumption per person in the United States as of 2009, 40 kilowatts to 200 kilowatts, approximate. Range of power output of typical automobiles megawatt, 106 watts, 1.5 MW, peak power output of a wind turbine 2.5 MW, peak power output of a blue whale 3 MW, mechanical power output of a diesel locomotive 16 MW, rate at which a typical gasoline pump transfers chemical energy to a vehicle 140 MW, average power consumption of a Boeing 747 jumbo jet 200 to 500 MW, electrical power output of a typical nuclear power plant gigawatt 109 watts, 2.074 GW, peak power generation of Hoover Dam 4.116 GW, installed capacity. The world's largest coal-fired power plant 18.3 GW, current electrical power generation of China's Three Gorges Dam. The world's largest hydroelectric power plant terawatt, 1012 watts. 3.34 TW, average total power consumption of the United States in 2005 50 to 200 TW, rate of heat energy release by a hurricane petawatt. 1015 watts, 4 PW, estimated total heat flux transported by Earth's atmosphere and ocean away from the equator towards the poles 174.0 PW, total power received by Earth from the Sun yottawatt, 1024 watts, 384.
What can you discover about static electricity? How about exploring the basic ideas of electrostatics?
All you'll need is a roll of cellophane tape. Any brand will do, the cheaper the better. Pull off a strip about 5 inches long, then fold over about 1/4 inch at one end to serve as a handle. Press the tape on your desk or a table. Mark the strip with the letter B. Make a second identical tape and press it down next to the first. Holding the two tapes by their handles, quickly pull them off your desk. They'll probably be attracted to your hands, so shake them until they hang free. Then bring them closer together. What do you see? You should see them bending, evidence that there is a force between them. If they don't bend, stick them on the desk again and again, pull them off. Do they provide evidence that there is an attractive or repulsive force between them? Well, say that pulling them off the table caused them to be charged. Although we have no evidence with what they are charged. They were obviously charged in the same way. So we can conclude that objects with like charges repel each other. By the way, well, work toward an explanation why they're attracted to your hands. Press the 2 strips back on your desk. Now make 2 more strips the same length and press them on top of the first 2 strips. Mark these strips T to identify them as the top tapes, as opposed to the B or bottom tapes. Slowly pull the T and B pair of tapes off the desk together. If they are attracted to your hand, then use the other hand to gently pat both sides of them over their entire length. That should remove any residual charge from the pair of tapes. If not, pat them down again. You have a pair of objects with no charge. Holding the 2 handles of the pair, rapidly pull them apart. Again, if they are attracted to your hands, shake them until they hang freely. Bring them closer together. Is there evidence of a force between them? Is it attractive or repulsive? You started with a pair of objects with no charge. Pulling them apart caused them to be charged, but not in the same way. Because they didn't repel each other, but attracted. Thus you can conclude that they must be charged differently, and objects with different charges attract. To keep your charged tapes, you can hang them from the edge of your desk or a desk light. Make a second T and B pair and see if the 2 T, top, tapes are charged alike or differently. If the tapes stop interacting, you can repeat the charging procedure as often as you like. Hang a T and a B tape so you can bring objects near them to see if there are forces between them. Make a list of the objects you tried and whether they attracted or repelled the T tape and the B tape. Try your finger. Then try rubbing a plastic pen on a piece of wool. Try plastic rubbed by silk or polyester. Try glass and metal. Do some objects attract both tapes? Repel both tapes? Attract one and repel the other? If they do the latter, you can characterize them as being charged like the T tape or like the B tape. Well, come back to understand why some objects can attract both kinds of charge, but no objects can repel both.
What is astrophysics?
Study of how astronomical bodies, such as planets, stars, and galaxies, interact with one another.
What is a series circuit?
Electrical devices arranged in a single line allowing only one path for the charges.
What is a converging lens?
Has at least one convex side. Its shape causes the entering light rays to converge, that is, come closer together.
How far away can FM and AM stations be received?
All electromagnetic waves travel in a straight line while in a uniform medium such as the lower atmosphere. Therefore, most radio waves only have what is called a line-of-sight range. That means that if a mountain range or the curvature of Earth were in the way of the radio signal, the receiver would be out of range and would not receive the signal. This is why most broadcasting antennae are placed on tall buildings or mountains to help increase the line-of-sight range. Waves with frequencies below about 30 MHz are able to reflect off the charged particles in Earth's ionosphere. This is referred to as skip. Instead of passing through the ionosphere and entering space as higher frequency electromagnetic waves do, the lower frequencies on the AM band can be reflected back toward Earth to increase their range dramatically. After sunset, the ionosphere's altitude permits stations to be heard thousands of kilometers from a transmitting tower. A handful of AM stations are clear channel stations. That is, there is only one station in the continental United States broadcasting on that frequency. Those stations can be heard across almost the entire country without interference from other stations. Broadcast FM stations, with frequencies 88 to 108 MHz, penetrate the ionosphere, and so can only be heard 80 to 160 km from the transmitter.